Okay, so if I could get you guys to stop chatting, that'd be lovely. Working together, Julia and Jose can pick 40 bushes of apples in 5.09 hours. Had he done it alone, it would have taken Jose 8 hours. How long would it take Julia to do it alone? So we set up our chart like we did before. We've got Julia and we've got Jose. You're going to have a time. We're going to have a rate. We're going to have hours together. So we're told that together they can pick 40 bushes of apples in 5.09 hours. Had he done it alone, it would have taken Jose 8 hours to do. So there's his rate, and we want Julia's rate.
Why is it always one person?
Because the rate is always something per time.
So it's never going to change.
It's always going to be, well, it depends on how the question is worded, but because the question is talking about how the entirety of the job is to pick 40 bushels. So we're going to call that the picking of the 40 bushels is the one job he's doing. It's not like he can paint a room and so now we want to figure out 5 rooms. Even then the rate would still be 1 room per X amount of hours. So we're still going to have the one job here is the 40 bushels. Yeah, so we're going to time the hours together by the rate, add them together, it's going to equal 1, because that is the one whole job is the 40 bushels. It's not always going to be like that. I mean, if they'd said he can pick 1 bushel of apples in this much time, and then it extended it, then it would equal 40. But because the 40 bushels is the total job, it's still going to equal 1. So it's going to be 5.09, well, it's going to be 1 over x times 5.09 plus 1 over 8 times 5.09 equals a job. Equals the whole job. Yeah. So that's it. Question number 5 on the next page. This one, the tank. Can I go back to which one? This one? Oh, okay. So we want 13.99 hours, so let's see if we can solve it. Okay, so we're going to times by 8x, times by 8x, times by 8x. My x's are going to cancel here, my 8's are going to cancel there, and so I'm going to get, that's going to be 40.72 plus 5.09x equals 8x. So we're going to get 40.72 equals, that's going to be 2.91x. $40.72 divided by 2.91 is 13.99 hours. Sorry? How is 13 point... sorry, what's the question? Because the time was given to us in hours, so this has to be hours. I'm not sure I understand the question.
No,
like what does 0.99 hours mean? Well, to convert this then into hours and minutes, you take the fraction of an hour and times by the number of minutes in an hour. So we're going to take that 0.99 and we multiply it by 60. That's 59 minutes and 24 seconds. So this decimal just represents a percentage of an hour, 99% of an hour. Okay, number 5, Rebecca wanted. A tank can be filled by pipe A in 3 hours, B in 5 hours. When the tank is full, it can be drained by pipe C in 4 hours. If the tank is initially empty and all 3 pipes are open, how many hours will it take to fill the tank? So this is exactly like the question I told you I could ask you but then didn't do an example of. So you've got tank A, we've got tank B, we've got tank C. We're going to have a time, we're going to have the rate, and we're going to have the hours, which is what I'm willing to bet we're looking for. Yeah. That's the thing we don't know. The time here is going to be, let's 3, 5, and 4, so that's going to be a third, that's going to be a fifth, that's going to be a quarter. But what is pipe C doing? It's draining while the other two are filling. So C is taking away from the job that's being done. So this is going to be 1/3 x plus 1/5 x minus what C is doing equals 1 full tank. Do I have to keep going? You want me to keep going? Okay. So now we want to get rid of those fractions. The smallest number that 3, 4, and 5 all go into is, you said it was 60? I think it is 60. So we're going to multiply by 60. So this is going to become 20x plus 12x minus 15x equals to 60. So that's going to be 32 minus 15 is 17. X equals 60 over 17. Which you don't have to give it to me like this, but this is the same thing. 17 times 3 is 51, so this would be 3 and 9/17, so this is the same thing. Or you run that thing through your calculator, and you're going to get 60 divided by 17 is 3.529, but I want to turn this thing into minutes. Minus 3 times 60 is, that's going to be 3 hours, 31 minutes. And then some seconds, but we'll leave the seconds off.
How did you get 31 minutes?
I took this and I multiplied it by 60, just the decimal portion of it, and times it by the number of minutes in an hour. And I got 31 point something. Actually, this would technically round to 32 minutes. Does that make sense? Okay. Question 6 is the same, if I'm not mistaken. 6 is exactly the same. Except, yeah, there's only 2. You add 1. Yeah, one's going to be positive, one's going to be negative. Is there anything else from the homework anyone would like me to go over? Yes. Which number 1? Actually, there was only number 1, because the other one, first one was evens. Okay, so number 1. It takes 6 hours for pump A. Pump B alone takes 8. We want to use 3 pumps A, B, and another pump C to fill the tank in 2 hours. At what rate should pump C be done in? Okay, so this is just like the first example I did combined with more people, except they're all contributing. So we're going to have A, B, and C. We want it done in 2 hours. Pump A can do it in 6. B can do it in 8. So that's going to be a 6th and an 8th. This is what we're looking for. Yeah? Making me cool with my setup? This is the time. This is rate. This is together. So it sets up the exact same way. So this is going to be 2 over 6 plus 2 over 8 plus 2 over x is equal to 1 whole job done. So it's going to be a third plus a quarter plus 2 over x equals 1. So I'm going to multiply 3, 4 into x. Or multiply all the terms by what common denominator? 12x. Multiply by 12x, multiply by 12x, multiply by 12x, multiply by 12x. We're going to get that 4x plus 3x plus 24 equals 12x. So we're going to get 24 equals 5x. Divide by 5, and we're done. You cool like him? Okay. I'm just short. Now at this point, I'm starting to shortcut some of the algebra that I'm doing here because I'm hoping that we're reasonably comfortable with the steps that I'm taking here. But that is that. Okay. Yes, sir. A tank can be filled by pipe A in 5, B in 8. When the tank is full and the drain is open, the water can drain in 20 hours. If initially the water was the tank was empty and the two pumps together and left the drain hole open, how long would it take? Manraj, did this example, or not my example, but did me going through question 5 make sense? 2 is exactly the same thing. Like almost. The only difference is it's not pipe C, it's a drain. But it's exactly the same thing. So I'm gonna, if 5 made sense, then I'm gonna let you try 2 on your own using what I did for 5. I don't think there's any other different questions in here. Yeah, no, 3 is the same. 4 is the same as 1. And 6 is the same as combination of 4 and 5, I think. So we'll leave you to play with that. If there are, I guess there aren't any. Is there any clarifying questions anyone wants to ask? Then we're going to move on. Here we go. New package. Go. This is going to be yes. This is the same unit. All of it's going to be on the test. You'll see why it makes sense. Why it's all the same. At least it makes sense to me. It just was really quite thick. If I attach this to the back of what was there, just go straight back. Back. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So, the entire previous chapter was all about equations. This was equal to this, solve for a variable. This is all going to be inequalities, which means things are not going to equal. Oh, and there's an extra page there that doesn't need to be there, my bad. So skip past this first blank page, flip the page over to here. And let's talk about inequalities. Okay, we good? Okay. Okay, so equalities. We had expressions that were equal to some value. We solved for it. We got one value for our variable. X equals 7, maybe. And that meant that x had only one option. To satisfy our expression, x had to be 7. Anything else wouldn't be valid. So and then we had our undefined expressions. We'd say, well, x is, our restriction maybe, x is not allowed to be 2, but if x is 3, well, then that's okay. So if we went through and we solved it and we found that, no, for this to be true, x has to equal 2, but if x is not allowed to equal 2, we say this thing's undefined because there was only one value that was true and it was not valid for whatever reason. In inequalities, this is not going to be nearly the case because in inequalities we don't have one valid answer. There are technically infinitely many valid answers to the questions that we're going to look at here. So if I had x, then this fun little symbol, and then 5, what does this mean to you using words? This is, yes, this symbol we say is less than. So x is less than 5. Why is that less than? How do you guys remember these things? In elementary school, there was an alligator, okay? Talk to me about the alligator. The alligator wants to eat the larger number. So why would we not say that, so the larger number here is 5? So why read this as x is less than 5, as opposed to 5 is larger than x? Because we read mathematics from left to right. Is it incorrect to say that 5 is greater than x? No. It's not incorrect to say that. In fact, we could very easily say 5 is greater than x. Both of those things are valid, but conventionally, and sometimes it's going to be totally necessary for you to be able to jump back and forth between these two. Conventionally, this is how we express it, because just like in English with our written word, we read left to right. Okay. So the next one. What would that expression be? Y is greater than 10. Oh, greater does not have an H in it. How about the next one? What does that symbol mean? Yeah, I'm gonna. A is less than the top part of the symbol or equal to the bottom part of the symbol, 45. And then the last one? P is greater than or equal to 100. So then on the side here, let's talk about what values could work for this. If x is less than 5, what is a value for x that would work? That would satisfy that equation. I heard 3. I heard 4. I heard 2. Are there more? All the negatives. Okay. So these are examples of valid values. Anything less than 5. So now all of a sudden we don't have one correct answer, we have infinitely many, because there are infinitely many numbers less than 5. What are some options for y is greater than 10? 11, sure. Kyla. 18, sure. 2,164. Love it. How about is less than or equal to 45? What are some valid answers for that, or valid values for that expression? 45. Cool. Give me another one. 39. Give me one more. Sure, 44, I heard 8, and I heard 10. So there's 3 more. The important one here is this one is now able to be included in our valid values because our variable is less than or equal to it. In these ones, we could not have 5 or 10. Here we can have 45. So then this last one here, valid values are going to be 100, 130, 200, etc. Anything larger. Cool, love it. How can you remember the difference? Well, I don't particularly care how you choose to remember the difference. I don't love the alligator example, even though that is what I grew up learning. It's just, yeah, there's a few different ways to recognize it. The arrow points at the smaller value. The alligator eats the larger value. However you choose to remember that, I'm just going to leave that open to interpretation for you. The thing I don't like about the alligator is it doesn't actually, like, it requires you go the step further and say, okay, well, if my alligator eats the bigger number, then what? If the alligator eats the bigger thing, well, what does that mean? It doesn't necessarily tell you, I don't know, I would just way rather us recognize that this is less than that's greater, like recognize the symbols for what they are, know their names. That would be like me looking at Angel and Amanat and saying, well, the glass is 1, or the non-glass is 1. Oh no, that's Angel, and that's Amanat, right? Like, or I could look at Angel and Kyla and pick on distinguishing factors between the two of them. The short-haired one and the long-haired one. Right? Like, I could, instead of talking about them by what they are and their names, I'm talking about a distinguishing characteristic. Yeah, I would just rather call them what they are, but you guys do you. I mean, sometimes it takes a while to remember names, but if we never remember the names, we have a problem. Yashvi, what's going on? Go for it. Take what you need. Yeah, so if from now on, that would be like, I mean, these things don't really have emotions, but if we as a class agreed never to call Angel Angel again, we're just going to call her Glasses. Which is good enough. We can call Angel Glass. We're not going to. Nobody start doing this. This would be, I will come down on you with the wrath of, bullying Angel if you do. But I mean, we're not going to call Kyla, or who else has got glasses on, Jasleen, or Manraj. We're not going to call them Glasses because we know their name. Angel's just Glasses now. That doesn't make any sense. Okay, call them what they are. That's just how I would prefer to go through it. But let's move on. So let's take a look at these inequalities. A, B, C, D, which ones are true and which ones are not true expressions? A is true. Why? Because 5 is in fact larger than, or 4 is actually less than. Okay, cool. How about B? B is also true, I heard someone say. Ooh, I heard both for C. Is C true or false? Why is C false? Because it's negative. Negative 2 is not greater than 0. Negative 2 is less than 0. What could we use to make it true? Without flipping it, what mathematical operator have I taught you about? We could use the absolute value. Is the absolute value of negative 2 bigger than the absolute value of 0? Yes, the absolute value is, because that's just the size of the number, if we remember back to the first chapter. But negative 2 is less than 0. Cool. How about this one? 3.4 less than 3.1. That is also false, I heard someone say on the left-hand side here, confirmed by Kyla. Okay, so we're going to use the symbols here. X is less than 5. What's that going to look like? It's hard to describe. Okay, X, and then this one. The alligator points at the 5, okay, if that's how we're going to remember it. Y is more than 10. Okay, hold on. Nika, you find the alligator. Why is the alligator confusing? That's fair. I don't disagree. But here in B, we're not actually using the language of greater than and less than. We're using is more than. So what's that thing going to look like? Which way is the arrow going to point? So if y is more than, then y is going to be greater than 10. That's a good question. What does at least mean? 10 meat is drawing me something with her fingers. I like it. At least means, am I allowed to include 20? Yes, that means 20 or greater than 20. If it's at least 20, it's allowed to be 20 or greater. So it's going to be greater than or equal to 20. Thank you, 10 meat, for your fingers in the sky. And then if z is at most 100, I'm hearing Carolyn suggest that it's smaller than or equal to 100. It's cool. Those are all correct. I love it. Let's write some inequalities for these things. Anna has less than 5 apples. How many apples does she have? So we want to write the inequality. So what is the inequality for this? A for Anna, or A for apples. Apples is? A is for Anna's apples. The apples belonging to Anna. So A is smaller than the number of apples. A is less than 5. So what are some valid values for this? Is negative 2 a valid solution to this? No, it's not. How many valids? Are there infinitely many options for this? No. We now realize this. Back before there was any context, we had infinitely many solutions for these things. But now we have context. What are the possible values for Anna's apples? What are all possible? 0, 1, 2, 3, or 4. Now, if she starts serving them, are we allowed to have fractional apples? Given the context of the question, could we have fractional apples? Sure. Maybe she started cutting them up and sharing them with her friends. How about Amen and his 25 comic books? How many comics does he have? What's the expression for this? C for comics, okay. Which one is it? C is greater than 25. So how many possible solutions are there to this? Technically, there are how many? There are technically infinitely many solutions to this. Are there infinitely many comic books in the world? No. So there is an upper value, an upper maximum value, smaller than infinity, but there are many. At least millions. Okay. C. Evan has 10 or more books. How many books does Evan have? B is greater than or equal to. Again, technically, how many solutions are there to this? Infinitely many, but can Evan realistically own infinite books? No, there is he can own a lot of books. There are reasonable and there are unreasonable solutions here, but as far as just what is given to us, there are technically infinitely many. Technically correct is the best kind of correct. What are you doing, Gavin? Trying to steal his watch? Or is it your watch? He stole your watch. Harmon has at most 27 frogs in her aquarium. How many frogs does Harmon have? H or F, sure, pick a variable, is she has at most. So her frogs are going to be less than or equal to 27. So how many different possibilities do we have for Harmon and her frogs? 0 to 27. Can you have a half a frog? Can you have a half a frog? No, you cannot have half a frog. Does that count as a frog you have? As a dead frog count towards the number of frogs you have? No, we would not count that. Like, practically speaking, no, but think about the practicality of these things. We would not count a dead frog in the number of frogs you have. The frog ceases to be. No, okay, so let's, no, it's okay, so here's a question for you. Your dog give birth to a bunch of puppies. I say, oh, how many puppies did she have? She had 6, but one died. So how many puppies does she have now? No, how many puppies does she have now? She now has 5 because one died. Okay? When we're talking about living things, there are no fractional living things. If you lose a leg, are you less of a person? No, you are a whole person who has less mass, but you are now not a fractional human being. Okay? Mind trap? Is that what you're talking about? No fractional living things. Okay? So, whole numbers 0 to 27 would be valid solutions to this. So, I'll just rattle this through real quick. Is each number a solution of the inequality x is less than 30? Which ones are valid, which ones are not? A, B, C, D. Is 0 is valid? Negative 5 is valid? 78 is not valid? D is not valid because it's not also equal to 30. How about the next inequality? Which ones are valid there? Any questions, comments, concerns as to why that is true? Greater than or equal to, yes. Okay, so if we're having trouble with any of these things, we can graph them on a number line. In fact, the best thing to do to represent a solution to these questions is to draw a number line. We don't need to draw number lines for equalities. Why? It's definite. There is only one, maybe two solutions to things depending on the kind of equation that you're given. But when we open this thing up to infinite possible solutions, demonstrating with a number line is actually a really good way to do it. When graphing an inequality on a number line, what we want to do is we want to find the value in question and do what? So let's just go straight to the examples and we'll fill in the holes later. The first example is x is less than 8. So here is all you need to do on a number line. We are going to assume that all number lines are made by reasonable people, and reasonable people do math left to right. So the only thing I technically have to put on my number line is what? No. 8. Okay? Okay? So, but there's a corollary to reasonable people. Reasonable people sometimes lie. Reasonable people sometimes make mistakes. So to verify your reasonableness as a human being, what we're also going to do is we're going to put one value on either side of our value in question. So 7 and 9 are going to be the ones that we're going to include here. The next whole number on either side. Now, I want to demonstrate that x is less than 8. How may I do this on a number line? We draw a line thing, pointing which way? From 8 to the left, okay. How do we demonstrate whether or not we're allowed to include 8? And how close to 8 am I allowed to get if x is less than 8? Is 7 less than 8? Is 7.5 less than 8? Is 7.9 less than 8? Is 7.9999999999999 less than 8? Yeah, so I can get really close to 8 without including it, right? How do we demonstrate that on a number line, might you suggest? You know what? No. I'll ask you it the other way. If I wanted to put that x was equal to 8, what would we put on the number line? To say that x is 8 on a number line, what would we do? On a number line, what would I do? An 8 and then a what? An x? Like right on top of 8? We could do that. We could also put we just put like a dot there, right? Like a closed in circle. So if I want to put a dot there, closed in circle, x is equal to 8. Now I want to say that we're allowed to get really close to 8 without actually being 8. What we're going to do is this. We're not going to put a closed in circle. We're going to put an open circle at 8. What the open circle represents is that I'm allowed to get infinitely close to 8 without actually touching 8. We call that an open circle. Did I say that already? Because it's not filled. So let's jump down to C. If x is less than now or equal to 5, I'm going to put 4, 5, and 6 on my number line. Because while I know that I'm a reasonable person, you can't trust me to be a reasonable person. So I'm going to show my reasonableness by including points on either side. And now I am not just less than 5 in all values that way. I am now also equal to 5. So to show my equalness to 5, we're going to close the circle. The circle is now closed. So let's go back up to the top here. When graphing an inequality on a number line, we want to find the value in question. And you know what? No, I don't like this. We're going to get rid of that. We're going to get rid of all this. We've just done what it is we are going to do. What's B going to look like? Someone tell me how to draw it. Carolyn. We're going to throw 9, 10, and 11 on our number line. The line is going to go to the right, okay? Open circle at the 10, my arrow goes to the right. Cool. Because now x is greater than 10. So everything larger than 10. Okay, D. What's D going to look like? Amanat. -3, -2, -1. An arrow going to the right from -2. And what's the dot on -2 going to look like? It's going to be a closed circle on -2 with an arrow going to the right. Love it. How about E? Carolyn. Cool, love it. Because p is greater than 0.5. And the last one, ooh, this is a tricky one. The variable's on the other side. How would I read that? 1.5 is greater than or equal to r. So what does that, how is that going to show up on our number line? So I'm hearing, Nika, you want me to put a 1.5 on here? On either side of these, I'm going to put a 1 and a 2. Okay, cool. Now, we know that the circle is going to be closed because it's also equal to 1.5. But which way is the arrow going to have to go? Because r, so if 1.5 is greater than or equal to r, that means r is going to be anything less than less than or equal to 1.5. Absolutely, this thing goes to the left. Cool. Love it. So now we can go the other way. What is, we got ABC here. What are these expressions? Oh, x, Rebecca, okay, is your variable. X is less than negative 4. Because my arrow points to everything smaller than. Love it. What's another way I could have written this? Negative 4 is larger than x. I could have written it that way too. Love it. Next one, B. How would I write that? 10 meet. Conversely, I also could have written it as cool. And then my last one, Carolyn. Love it. All are valid. The difference between the solution of a linear inequality and a linear equation, we've already talked about these. Linear equations have a finite number of solutions. Sorry. Usually 1 or 0. A linear inequality can have infinite solutions. The reason that I'm lumping this in with the rest of, or like the previous chapter, is because when we start to solve these things, the techniques are going to be exactly the same, because these are the idea is everything here is linear, meaning, well, I'm not going to be squaring anything first of all, so there's going to be easy algebraic expressions, but the techniques are very, very similar. Not exactly the same, but very, very similar. So there is 25 minutes left. This, I'm hoping, is largely review for lots of you. Some of it might not be, but the ideas of greater than or less than should definitely be something you're familiar with. If you flip the page, there are questions 2 to 13, and I have photocopied the textbook for you, so as to not, have to carry that thing around. I want you to do all of questions 2 to 13. Two's up at the top. Two to 13. Actually, that's not. Do I want you to do more? I also want 14. I'm also adding 14 to this. I want you to see what you can do with 14. As always, because I have given you photocopy from the textbook, where could you find, how do you check your homework? There is a textbook answer key in the Google Classroom. You betcha. Okay, on your mark, take giver. Grab your lined paper, your separate paper, and get to it. Welcome to Inequalities.